Hello everyone, assalamu alaikum. Welcome back. This video is a continuation from the previous video, which is finding the point of inflection. So this video will teach you about sketching the graph of a polynomial function where it focuses on drawing or sketching the graph of x to the power of 4. In other words, it is called as quartic functions. So this is a new experience for you guys. It is a new syllabus for all of us. So let's learn on how to sketch a quartic function. So let's read this concrete example. For the function fx equals to 3x to the power 4 minus 4x cubed, describe the concavity. This is our first goal. Describe the concavity of the graph. And the next goal is finding the point of inflection, if exists. And then last one is sketch the graph of fx. So we have 3 goals here. Let's focus on one by one. Right, so make sure you highlight your function there, your quartic function, alright? So this quartic function is fx equals to 3x to the power 4 minus 4x cubed. So in order to find the point of inflection or its concavity, we cannot forget about this first step. This is a very powerful step that you must memorize, alright? So it is the second derivative. Okay, you must find its second derivative and then you make it equal to 0. This is a very important. If not, we cannot move on to the next step. So before you go finding the second derivative, you must know what's your first, isn't it? So your first derivative is 12x cubed minus 12x squared. So after you have found your first derivative, you can go on with the second one. The second derivative will give you 36x squared minus 24x. And then there you go, your first step. Make sure you will always equal it to 0. So let me highlight this part. This is a very important part, which is you must highlight it. You must make sure you remember, okay? You must remember that it is equal to 0 for every step, yeah? Every step. So here goes your second derivative, equal it to 0, and then you factorize it down, and it will give you equal to 0 again. Make sure it's equal to 0 for every step, yeah? And then last one, it will give you 2 value of x. One is x0, one is 2 over 3. And so when you have 2 value of x, it is showing to you that we are actually having 2 IP. Okay, oops. 2 IP means 2 inflection point. We have 2 inflection point. It is just that we do not yet have the y coordinate. We only have this x coordinate, isn't it? So this is the first step. But you can just wait for a moment. We will get to that y coordinate later. But it is enough that you know that we will see 2 inflection point for now. And then go to the next step, which is the table. So this table is helping you to find its concavity. Maybe it is best to write down here as concavity, because this is a concavity table actually. This table is to find concavity. Alright, so it's up to you whether you want to write down conclusion or concavity. So here we go. You must write down your value. Which one is the least number? The smallest number, which is 0. You must write it down there first. and then the biggest number will be at the back, which is 2 over 3 will be there. So there you go. You will have, you know how to find these intervals. There are 3 of them. Because of 2 inflection point, you will have 3 intervals. Okay, and then you sub in the test value. Okay, -1, you can use -1 or -2 or -3, up to you guys, as long as it is inside of this interval. And this one also, as long as it is inside of this interval, and same goes to this one. You can choose number 2, 3, and so on, whatever. Just choose a number that it is easy to sub in to the second derivative. Okay, where is your second derivative? There you go. This is your second derivative. So sub in this value into the second derivative function, and then you will get a sign, whether it's positive sign or negative sign. And then after you do that, you will know its concavity. So this first interval will give you a positive sign, so it has shown us that this is a concave up, while this one is a negative sign, it will show you a concave down, while this one is a positive sign, it will show you a concave up. So please write down it neatly, and then make a conclusion, a very good conclusion, because we need to describe, isn't it? We need to describe it's the concavity of the interval. So when you described it, please write down its interval. Okay, so when f is concave, so f is, okay, put a conclusion, just write down the function f is concave up on the interval of -infinity until 0 and 2 over 3 until infinity. So this will give you 1 mark. And the next conclusion is f is also having a concave downwards on this interval, only at this interval part, where it is from 0 until 2 over 3. There you go, you will have 2 marks there. So you have actually finished fulfilling the first goal. Now finding the next goal, which is point of inflection. So the third step is finding the point of inflection, where you just sub in these 2 values of x into its function, the quartic function. You have sub it in and you will get the y coordinate. Okay, you know that this is the y coordinate, right? And then you just make a conclusion. You're saying that, oh, these 2 points are the points of inflection. There you go, you get 1 mark for listing out both coordinates. Yeah, both coordinates is important. Don't stop here, and don't just stop here. You must come up with its coordinate. Okay, and of course the last part is sketching graph. This will be our final goal, which is to sketch the graph. So in order to sketch the graph, please remember we will need to find its minimum or maximum point. So in order to find its minimum or maximum point, I know all of you have understand that we need the first derivative. Okay, we need the first derivative, in which it must be equal to 0. And then this is your first derivative, equal to 0, and you will have a new value of x. Okay, this is your value of x, and of course you will also need to find the y value, and it will give you a coordinate. But the thing is, this coordinate, you do not know whether it's a minimum point or a maximum point, right? You do not know yet min or max. Hang on, you do not know whether this is min or max yet until you do what? Until you do the second derivative test, this one. By using the second derivative test, sub in this value into the second derivative function, and there you go, you will get positive sign, but this positive sign means it is a minimum point, right? So you have learned this before in using the second derivative test, so I don't need to explain further. But so now we already know that, oh, this is a minimum point. So So basically this quartic function, this quartic function fx consisting of a minimum point. There is only one point, therefore we know there is one point, so it's enough for us. So how many points do we have now? We have inflection point. You see, this is one point. Yeah, both of them are inflection point, of course, but we remember we also have a minimum point. So these 3 points are important, are crucial for us to sketch the graph. So in order to sketch the graph, of course, we will, list out, we sketch first, okay? We make sure we write down the coordinate, the important coordinate. What is that? 0, 0. Yeah. Do we have 0, 0? Yeah, over there. It's at the origin. How about another point, 2 over 3 with the negative 16 over 27. Yeah, there we go. That is our inflection point. So we have 2 of them. This is 1, 0, 0, coordinate 0, 0, and this one is another coordinate of inflection point. So these 2 are the inflection point that you must focus at first. And then you must also remember that you will need to find that you will know that you have a minimum point, and so I am labeling, this is the word, labeling the 1 and -1, and therefore you just put a dot or an X, to describe that, oh, you have a minimum point. So when a minimum point, it is showing you that oh, it is this shape. It is a smiling shape, isn't it? So smiling shape will be here. Okay, we know that for sure. It is just that we have yet to know what shape it will be here. How do I know it's going up and it's not going down? How do I know this is going down and not going up, So there are a lot of questions here. But one thing that you have to know about quartic function, which is x to the power 4, it is always will give you the basic shape, The basic shape is always upwards, like that. You do not know whether it's like this or like, it will give you like a W kind of shape, but just make sure you understand that it will always, the end of the graph will always upwards because of this power 4. So the basic shape for quartic function is always going up the end of the graph, okay? Because it is the same as the quadratic. Positive quadratic will always give you a smiling, right? Same goes to the quartic function. Quadratic and quartic function is the same because of the power, an even power will give you this kind of shape, while cubic and quintic is a bit different, right? So just look at this basic shape and you understand already. So that is why that the graph, the end of the graph will always give you a positive direction. Positive infinity is going up and up to the infinity. So you already understand the basic shape. You already understand that we have a minimum point and also 2 inflection point. It is just now you need to know that you need to compare with your concavity here. So the interval, say from 0 to -infinity, it is concave up. From 0 here to -infinity, it's concave upwards. So it's sort of like smiling, but you don't have to draw full smiling graph. You can just draw half of the smiling graph and stop there. And then because it says between this interval 0 until 2 over 3 here, it must has a concave downwards. From this description, it's very obvious that from this interval you must concave down. That's why it is just halfway smiling and then halfway of sad, until it stopped at this point 2 over 3 because of this interval part showing you that it is concave downwards. And you don't have to draw all of them. You can it can also happen to be half of the curved, half of the concave down, because that is what it is needed, so that's why this is only half of the shape is concave up, while half of this shape is concave down, and then it is going up again, and it is going up again from this part to infinity, from this 2/3 until infinity, until positive infinity is going up. That is why that is the quartic graph that you will see. The kind of graph that you can draw perfectly if you understand where is your inflection points, and also your minimum point, and also your basic shape of the quartic function. Do you get me? So you must first of all determine all of the point here, 1 to 3 points, if there are 3 important points to figure out, that you already know it, and you must also know its basic shape. So these are the things that you need to focus on before before you sketch the concave up, the concave down, and the concave up again. You just try to find the important point first, then you think of its concave up or down. You get me? So after that, you need to find its what do you call this, y-intercept, okay, just to double check. And this 4/3 is actually coming from finding the x-intercept when y is 0, because in exam we need to find its intercept, because the graph go across the x-axis, so we need to find its value. So here we go, don't forget your intercept, and you will be fine. You will get almost 5 marks here. So that's it from this video. Thank you for listening. All the best.